class! Today we're going to start talking over chapter 14, which covers chemical kinetics. Now, section 1 is very short and it is concept based, so this lesson should not take very long. So let's go ahead and get started. So as a little introduction, so far, every single lesson that we've been talking about, we've only cared about the beginning or our reactants and then our products at the end of chemical reactions. But it doesn't really actually tell us what happens in the middle. It doesn't tell us which chemical bonds are broken, which ones are formed, and the order that these events occur. And specifically, we have not talked about or learned how fast do these reactions occur. So we're going to be using the term reaction rate a lot within our lessons over the next several. So reaction rate is defined as the speed at which a chemical reaction occurs. Some chemical reactions occur just in a fraction of a second, and others occur over thousands and thousands of years and take a lot of time. So the area of chemistry that's concerned with the speeds or rates of reactions is called chemical kinetics. And why do we care about this? How does this apply to our everyday life? Well, we have to know how quickly a medicine is going to work in our body. Scientists use it to figure out whether the process that forms and depletes ozone in the atmosphere are in balance, so we're not losing our ozone layer and affecting global warming. And to such industrial challenges, such as developing new catalysts to help reactions occur faster. So section 14.1, we're just going to solely focus on factors that affect reaction rates or how fast these reactions happen. So there are 4 factors that allow us to change the rate at which any reaction occurs. And those 4 that we're going to talk about is the physical state of our reactants, whether they're a solid, liquid, gas, or aqueous solution. We're going to talk about the reactants' concentrations. So remember, concentrations is abbreviated with a capital M because that is molarity. We're also going to talk about the reaction's temperature. And then, is there a catalyst present? And we're going to define what a catalyst is. So let's focus on physical states of reactants first. In order for reactants to actually make products, reactants have to come together to react. And they most readily react by colliding with one another. And so the more they collide, or the more they're going to react more rapidly. So with this, there are 2 different types of mixtures or reactants we can have. We can have homogeneous reactants or heterogeneous reactants. So homogeneous, this means exactly what we learned in regular chemistry. This is when our reactants are in the same phase. And fun fact, the more homogeneous a mixture of reactants are, the faster those molecules are going to be able to react with one another and the faster that the process is going to happen. Heterogeneous, though, this is where our reactants are in different phases. And so one thing to note is heterogeneous reactions that involve solids tend to proceed faster if the surface area of the solid has increased. So a good example of this is whether a powder versus a pill works better. And typically, powders work better because you have more surface area for a reaction to take place versus a pill. But oftentimes, a lot of doctors give things in pills because they don't want the reaction to happen until it gets to a certain part of the body that it wants that reaction to take place. The second thing is our reactant concentrations. So the more concentrated something is, or the higher the concentration, usually most chemical reactions proceed faster. So here the statement says most chemical reactions proceed faster if the concentration of one or more of the reactants has increased. And the reason for this is if you increase the concentration, that means there's going to be a higher frequency or a higher rate in which these molecules collide, and therefore we're going to have more chance of this reaction occurring. A good example of this is steel wool. We burn this in my chemistry class to figure out that this is a chemical reaction. And you're going to notice whenever you put a match to steel wool that it actually burns pretty slowly in air. And it's because air only contains about 20% oxygen. But if you were to put that in a chamber of pure oxygen, which means pure means 100%, so I'm increasing the concentration, that steel wool would not burn slowly, it would burst into flames. The third thing we're going to talk about is reaction temperature. So reaction rates generally increase if you increase that temperature. The reason for this is because when you increase temperature, their kinetic energy increases. That means they're moving faster and more rapidly. That means they're going to be colliding more frequently and they have a lot more energy. A good example of temperature affecting reaction rates is looking at milk. If you leave milk at a warmer temperature, such as outside the fridge, bacteria are able to actually break down that milk faster, and milk tends to spoil easier at room temperature. Whereas if you put it in the refrigerator, that's at a lower temperature, the reaction cannot happen as quickly, and so milk tends to last longer in the refrigerator. And the last one is the presence of a catalyst. Now, to define catalyst, these are basically any reagent or chemical that increases a chemical reaction but is actually not used up. So, catalysts are not reactants because they are not actually consumed in the process, and they're not products either. They're kind of that intermediate, they help things along. In fact, catalysts are super important and they play a very important role in humans and any living organisms because in our body there are thousands of catalysts and we call these catalysts enzymes. These are basically protein molecules that act as catalysts to help the reactions within our body happen faster. So the reaction of breaking down food, the reaction of muscle contraction. So catalysts and enzymes are very, very important in reaction rate. And like I said, that was a very short, easy intro lesson. Let me know if you have any questions, and I hope you guys have a great day.